This video covers some basic things about polymer, that is introduction to polymers. Kindly subscribe my channel, like videos and share the videos. See, this picture gives something like monomer is formed into polymers. The monomers is a single entity. They join together to form a long chain compound. And that conversion from monomer to this polymer, called it as a polymerization. So then what is monomer? The monomer is a small molecules having two or more bonding sites which combine with each other to form polymer molecules. Like the one example is this one. So they possess two bonding sites, that is the another molecule can bind either this side from this side or this side. So there is two bonding site. That means a polymer monomer is a small molecules having two or more bonding site which combine with each other to form a polymer molecules. So they combined with each other forming this long run compound. So forming a polymer. And the conversion, the monomer undergo polymerization if it is at least bifunctional. They should possess two functional groups. And what is this polymerization? It is a process by which low molecular weight compounds called monomers are converted into high molecular weight compounds called polymer. Okay, the molecular weight of this polymer is very low, whereas this one is high. That conversion process of transformation is called it as a polymerization. Then polymer and formed compound, what we called it as a polymer. A polymer is a macromolecule. It is a macromolecule or a Gantt molecule having high molecular weight, formed by linking together a many small repeating units. Each time we observe the same unit having same repeating unit molecules. And the bond observed in the polymer is a covalent bond present in the polymer chain, and their properties, this polymer properties, entirely different from that of monomers. And these polymers always having a high molecular weight of several thousands. And the first, if you history that shows the first polymer, organic polymer synthesized is PVC, that is polyvinyl chloride, in the year 1838. And thereafter the polystyrene is discovered, that is around 1839, and that process of conversion of monomer to polymer called it as a polymerization. The monomers are small molecules having two or more bonding sites which combined with each other to form a polymer molecules, and the polymer is a Gantt molecule linking together with the small molecules. See, a polymer is a macromolecules or a Gantt molecules of high molecular mass formed by linking together many smaller repeating molecules. And that smaller repeating units are called it as a monomers. They should possess at least two functional group called it as a bifunctional. The bond that present in a polymer is usually a covalent bond, so that the properties of the polymers is entirely different from that of the building block monomers. The process by which low molecular weight compound called monomers are converted into high molecular weight compound called polymer, and that process called polymerization. And I already informed that is the ethene molecules is a bifunctional. What is that functionality? It is the total number of functional group or bonding site present in a monomer molecules are called it as a functionality. Depending upon the number of functional group present in the monomer, we define like bifunctional, trifunctional, polyfunctional, etc. And there is a conversion. So the molecules like CH2 double bond CH2 containing n repeating units undergo polymerization to form the chain length of CH2 with N number. So here we will come across a one term, called it as a degree of polymerization of this particular polymer is N. So the degree of polymerization is the number of repeating units present in a polymer chain. Say if I take 100 or 1000 molecules so of this ethylene molecule, so forming polyethylene, which contains 1000 monomer units. So the degree of polymerization of this particular polymer is 1000. So which indicates the chain length as well as molecular weight of the polymers. Now coming to the classification of polymerization or a polymers, there are different way the polymers are classified. So now I'll take the first one based on the origin of source. Okay, then normally it is broadly classified like based on the source, based on the structure, based on the molecular force, or we may classify it based on the mode of polymerization. Based on the origin, they classified into three categories: natural polymers and synthetic polymers, and the third one is a semi-synthetic polymers. As the name itself indicates, here the natural polymers say these are the substance of naturally origin and mainly found in plants or animal origin like starch, cellulose, like components, proteins. They are all comes under natural polymers. Another thing is a synthetic polymers. The polymers are synthesized in the laboratory. They are mostly they are man-made polymers like Teflon. For example, it is Teflon, maybe nylon, like different polymers, PVC, polyethylene. They all comes under synthetic polymers. In between natural and the synthetic polymer, we may come across one more type of polymer, called it as a semi-synthetic polymers. They mostly derived from the natural polymers by chemical modification. Usually, they are derived from naturally occurring polymers by chemical modification, like vulcanized rubber, cellulose nitrate. So these are comes under semi-synthetic polymers. Then second category is based on the structure. How the polymers are arranged. Based on that, we classify the polymers into linear polymers, branched chain polymers, and cross-linked polymers. So in a linear polymers, the monomers are linked to form a linear chain. So they form a linear chain. A straight run compound is observed, like polyethylene, polystyrene. So these all comes under a linear polymers. The second category is a branched chain polymers. In these polymers, the monomers are joined to form a long chains or branches of different lengths. Like one long chain compound aligned with this one, some branches are present. So that type of polymers, what we call it as a branched chain polymers, like starch. So starch is a branched chain polymer, glycogens, etc. Then third category is a cross-linked polymers. It is highly cross-linked one. So the large number of molecules are linked together. Highly a three-dimensional structure is observed. Units of cross-linked together to form a three-dimensional network. The good example is bakelite. The plastic is a cross-linked polymers. So this category is based on the structure. Then the third one is based on molecular force. They categorized into elastomers, fibers, thermoplastics, thermosettings. The elastomers are the polymers having weak intermolecular forces between the polymer chain. Here, the two polymer chains are bound by a weak force of attractions. This weak force permit the polymer to stretch. You can stretch that polymers. They have an elastic in nature, possess elastic character. One good example is a rubber, vulcanized rubber. Then the second one is a fibers. These are the polymers which have a strong intermolecular forces between the chain. The two chain molecules are held together by a strong force of attraction. Usually a hydrogen bond or a dipole-dipole interaction is observed. The good example is nylon 6,6. Here hydrogen bond between the fibers is observed. Then thermoplastic polymers. And these polymers, these are the polymers in which intermolecular force of attractions are intermediate between these of elastomers or the fibers, and these polymers do not have any cross-linking between the chains and can easily be modified by heating. Just by giving heat, we can get a different or the article of different shapes. That is, the thermoplastic soften on heating, so they become soften on heating, and cold, when it is cold, it becomes hard. A good example is a polyethylene, polystyrene. So this here becomes a thermoplastic polymer. Another kind of polymer, and again it may be taken as based on the thermal behavior, based on thermal behavior classification, that also comes. So thermoplastic and thermostatic. And a thermostatic, they have an extensive cross-linking. Once you give the heat, it get collapsed and they can undergo a permanent changing on heating. A good example is a bakelite plastic. Here, it can be molded into desirable article repeatedly, thermoplastic, but in thermosetting, once it is heated, it undergo permanent change on heating. So these are the 4 types of polymers classification, that is based on the molecular force. Then based on the mode of polymerization, they are mainly classified into addition polymerization and the condensation polymerization. A polymers which are formed by the addition of repeat or the monomer units without the elimination of small molecules are called as addition polymers, like polyethylene. The example is polyethylene. See, repeated this units is bind. Ethylene unit is repeatedly joined together to form a long run compounds, and without elimination of byproduct is observed, and that polymer is called as a addition polymers, and the technique called it as a polymer addition polymerization technique. And the technique is a condensation polymer. During condensation polymers, there is a removal of a small molecules, formation of small molecules like hydrogen, water, HCl, ammonia, etc. That is, a polymer is formed by the condensation reaction between the 2 or more monomers units with the elimination of small molecules, simple molecules like water, HCl, alcohol, etc. That is called condensation, are the formed polymers called condensation polymer, and the technique called it as a condensation polymerization. The good example is a terling. Terling form a polymer under, or it is a condensation polymers. And even nylon is a condensation polymer. So this is about the classification of polymers. Say 4 category, or you may be taken under a 5 category. If you place thermal behavior, based on thermal behavior, if you place it separately, so the classification of polymers becomes under 5 category. Okay.